Okay, now when we know how to create fluids, we can start characterizing the fluid. We have three types of characterization in HydraFLASH. The first one is the fluid characterization, which when you have a single flash data and you have GOR, flash gas molecular weight, stabilized oil molecular weight, and the density of the dead oil, and you have the gas and dead oil compositions, you can characterize this fluid, you can tune the model, you can tune this fluid, you can perform any calculations, including flash, saturation properties, or hydrate calculations. But if you want to perform wax or asphaltene calculations, you need to characterize the fluid first with either wax or asphaltene data. The reason for that is the model that we use for wax calculations and asphaltene calculations in HydraFLASH. For wax model, we use Coutinho model, which needs to know what are the normal alkane fractions in the oil, because it assumes that only normal alkanes form wax phase. So the model needs to know which part of the composition is actually normal alkanes. So this wax characterization helps to extract the fraction of the normal alkanes using the wax content experimental data. So if you don't have the wax content experimental data, you probably won't know what are the waxy fraction of your oil sample. But in HydraFLASH, we use another way which I explain later. Similar to that, in asphaltene calculations, the engine behind asphaltene calculation is PC-SAFT model. So we need to know what are the asphaltenic compounds in the mixture. So we need SARA analysis for that. So when you add inter-SARA analysis data to the characterization, then you are introducing asphaltenic fractions to the model, and the model can do predictions for you after tuning. So let's start with fluid characterization. To perform a fluid characterization, you just need to navigate to Fluid Management tab and press this button, Fluid Characterization. This will open a new window. You have the composition information section, you have the characterization specification, and you have the single flash data information. And then in this section, you can add the single flash composition, and the characterized fluid will be shown here. So first, I need to activate a reservoir fluid, which is here. I have the composition before. So this is a list of compounds I have. And in an Excel file, so imagine from a PVT report. So this is the composition from the Pedersen book. So I have the single flash data. This is the flashed gas, and this is the stabilized oil, flashed oil. And I have this PVT information data here from flash gas molecular weight, stabilized oil molecular weight, GOR in standard cubic feet per barrel, and the dead oil density. So what I want to do is that I enter this information into this window and perform a characterization. So you can enter this data one by one, but it's just easier to just copy them and paste it here. But you just need to be careful that the order of this data, order of these compounds must be exactly the same as the order of the compounds you're entering here. Otherwise, you're entering the wrong values. But again, always you can enter one by one here, but it takes a little bit more time. So select this data, come here and right click and press save and press paste. So we paste all the data here. And then I need to enter the GOR and other data. So the GOR is 881. Stabilized oil density is 0.84. And the flash gas molecular weight is this one. And the stabilized oil molecular weight is this one. So I entered all these data here. And then in this section, you have this characterization specification. You can tell HydraFLASH how many pseudo components you want. You can have from 5 to 50 pseudo components. And also you can have this automatic number of pseudo components, or you can have the mix only. So when you choose the mix only, using this data, it only mixes this gas and stabilized oil. That's it. But when you choose automatically, HydraFLASH takes these two compositions, characterize it, and lump these single carbon numbers from C6 to C20 plus and make an efficient and automatic number of pseudo components. Or you can select manual and it tells HydraFLASH that I need 26 pseudo components. But you just need to remember that when you increase the number of compounds, automatically the speed of calculation decreases a little bit. So I would recommend that just press automatic. So that would be the most efficient way of doing this. And in this section, you have the characterization basis. You can say that I have a gas and oil or have a single fluid. If you choose I have a single fluid, it shows you only the reservoir composition that you have given when you were defining this fluid. And then it can characterize it to a different number of pseudo components. But I want to mix these two fluids, gas and liquid, and the mole mass basis is mole. If you change it by weight, you change to weight, but this is mole. So you can have it mole. I've entered all this data. The number of pseudo components is automatic, and you can press characterize here button, and it will characterize it for you. So you can see these pseudo components from this F stands for fraction, from C9 to C6 to C9, C10 to C12, 13 to 17, and you can see 1, 2, 3, 4, 5, 6. Automatically, HydraFLASH created 6 pseudo fractions. And these are the compositions, the mole fractions. And then you can choose a name for this characterized fluid. So this characterized is just too long, this suggested name. So I press fluid characterized. And the base fluid is reservoir fluid T3.7. And then when you're happy with the results, you can save it to database. Characterization fluid successfully added to the active database. Okay. Now, as you can see, this fluid is now active. For wax and asphaltene characterization, this is the exact same thing, but the fields that the information you need to enter are different. So for wax calculation, you navigate to the fluid management tab and press wax characterization. The wax characterization tab, the same thing, you need to select the fluid and select this fluid, and then the single flash data, GOR, molecular weights, and dead oil density. The number of pseudo components, you can choose to be manual or automatic, or manual or automatic. The number of pseudo components and the number of paraffinic pseudo components. So just leave these two options automatic. But if you have a very specific calculation and you want a specific number of pseudo components, you can change it to manual, but we recommend it to leave it as automatic. So again, let me enter the values I have from this Excel file. It's just faster. Okay, press paste as explained before. Okay, so GR was 881, flash gas molecular weight was 25.98. The stabilized oil density is 0.84, and stabilized oil molecular weight is 195.13. Okay, so you have this section as paraffinic distribution. You can either introduce a wax content data, which you usually have in a PVT report, which has measured using UOP46 method, and it gives you the content of waxy compounds in your sample, in your dead oil sample. So when you enter 3.5, the default value is 3.5, you can see to 8, 10, whatever it is, 10. So for this case, I assume that it's 8.9 mass percent. Or if you don't have this value, you can still perform a wax calculation. But how? You can choose this PNA distribution. What is this PNA distribution? This PNA distribution uses some correlations to extract the number of the mole fractions of normal paraffinic from the fluid. So it makes an estimation of, from the molecular weight and the specific gravities you introduced to the system, how much would be the possible, there's an estimation of the normal alkanes in your system. You can press characterize now, and it shows you this. But because this is a rare case, because we only consider this for users who don't have an estimation of what is the wax content. They still can do the wax characterization, and then when they tune the model using the WDT or WAT data, which I will explain later, the model can work. But it is safer that you use the wax content data. If you have any wax content data, please enter this value here, and then single flash information, and these two options are automatic, and then you press characterize. So in this section, in this grid, you will see the composition of the characterized fluid. So you have some gases: nitrogen, carbon dioxide, methane, ethane, propane, butane, and I-pentane, molecular weight and mole fractions. And also you have two sets of pseudo-components. The first pseudo-components are general fractions. Like when you have, for example, in a PVT report, in a composition, you have SCN20 or C20. It means that all the hydrocarbons with the carbon number of 20 are considered in this fraction. But when you extract the normal alkanes, that means that all the mole fraction of all fractions are non-normal alkane fractions are now 0.13, between 6 to 9, and all the carbon numbers, non-normal alkane carbon numbers more than 39, this is the mole fraction of them. And then the number of the fraction of normal alkanes from normal C20 to normal C24 is the mole fraction, and the normal C42 plus are in this fraction. So this will allow the Coutinho model, which is the engine model for wax characterization, to know, okay, these are the normal alkanes. So I know that these fractions can form wax phase. And then when I can know what is the concentration of these compounds, I can now tell you how much will be the WDT. Okay, so let's don't worry about the WDT and WAT for now. It's only for characterization, and you can copy them you can just press Ctrl C and copy them to an Excel file. And when you're happy with the results, you can choose a name for this new fluid. So I call this VAX CH, which stands for characterized, and then press to save database. Now, this fluid has been activated and has been added to this active database. Okay, so let's do the same thing for asphaltene characterization. Again, I press asphaltene characterization, it will open a new window, and I need to enter different types of data. So first, I need to choose the reservoir fluid, which is the base for this characterization, and then enter the single flash data. So to do it more quickly, I copy them from here, then paste it here, and the GOR is 881, it's 25.98, density is 0.84, stabilized or more corrupted is, I forgot it, okay, it's this one, and then I need to add the SARA analysis report. Okay, SARA analysis report I have is 70% of saturates, 25% or maybe 22% of aromatics, add up to 95, then 3% of resins and 2% of asphaltenes. So that's a very optional SARA analysis, but you need to enter the values you have in your PVT report. If you don't have the SARA analysis, unfortunately, you cannot perform SARA characterization or asphaltene calculation, because we need to know what is the asphaltenic fractions in the oil to perform the asphaltene calculation. So I'm happy with the data here, the single flash data, the SARA analysis, and I have entered the single flash data, and I just need to press characterize. As you can see in the characterize section, you can see the gas compounds like methane, propane, carbon dioxide, nitrogen, and you have 4 pseudo components. These pseudo components are called heavy gas, saturates. We show resin and aromatics in the same pseudo components because of the efficiency of the calculation, and then asphaltene pseudo components. So this is the characterized composition for asphaltene calculation. And if you're happy with the data, then you can add this to database. As you can see, this has been added to database. The reason we have, as if I explain again, 2 different characterization for VAX and asphaltene is that we want to introduce the different type of models, type of compositions to the model, so it can calculate efficiently how much would the VAX or asphaltene precipitated. So again, in order to perform any calculations like flash calculations, saturation properties, anything, you can characterize fluid, or you can use the fluid you have created using the create fluid module. But for VAX and asphaltene, you need to perform VAX characterization and asphaltene characterization. For VAX characterization, you can tune the model using the saturation properties data or the PVT lab testing data. And for asphaltene data, you can tune the model using the onset asphaltene onset data, or the titration data, or saturation properties data. And we will going to talk about the tuning in the future videos. But for now, we have learned how to first characterize a fluid, how to clean a contaminated reservoir fluid, how to mix different type of fluids, and how to perform wax or asphaltene characterization. The only difference between this fluid characterization, wax characterization, and asphaltene characterization is the type of data you need to enter. For wax calculation, you need to enter the wax content data, and for asphaltene characterization, you need to enter SARA analysis data.